I want you to leave this video having a lot more comfort and understanding around pulling evacuations, aka pulling a vacuum, on a air-cooled chiller and some of the things we look out for, practices, and equipment that I use to do that. Hey, how you doing? I'm Holden Schamberger with HVAC Time and Chiller Academy. I specialize in chiller systems. We're going to talk about some chiller evacuation. Now, this is specifically going to hone in on air-cooled side of things. I'm going to do a separate one on water-cooled as they tend to be a little bit different. But you really need a proper setup for equipment. And what I mean by proper setup, if you haven't invested in large diameter evacuation hoses that are properly rated, then you need to start doing that now. Even if you just go buy one half-inch hose, so be it. It's got a quarter-inch port on one side of it. In the chiller world, you're going to really struggle getting proper evacuations if you do not have the proper hoses. Forget the machine itself. That's one of the things not thought about a lot of times is our hoses itself and the fact that it doesn't matter how big the pump actually is. A lot of the time, we're not ever even supplying the pump with the CFM volume it's capable of handling. We're just not. And that's because of our hoses. Our hoses are the main restriction, not the pump. My my preferred, my preferred out there as a air cooled technician or just a heavy commercial tech, it's going to be the Appion Tez 8. It is an amazing pump. Now, it has its own nuances. One of the things that has come up recently is its ability to manage oil or the oil temperature. If you take care of the pump and you learn some of its characteristics, there's actually not an issue at all. I've not had a problem with that. But it's just something to be aware of. Anyway, the Tez 8 is my ultimate go-to. It's very portable. It's very easy to use. You can hot swap the oil out, and it's got a lot of ports on the tree. Now, it's an 8 CFM pump, but reality is you'd have to have a very serious setup to feed that pump an actual 8 CFM worth of vapors coming to it. So anyway, my point being, invest in your hoses. Okay, that's my evacuation pump recommendation, my vacuum pump. But if you don't have the hoses to support it, it's not really going to matter what you have or what you use. I don't have one particular Micron gauge at this point that I think is just phenomenal above the rest. I think they all are fairly decent, and every one of them's got their issues. I used to recommend a Yellow Jacket one pretty heavily, and I know that the Blue Vac makes a fantastic one, but it's really friggin' expensive. So it's hard for me to recommend that one just because of the price point. But it is fantastic. So that is the one I've been using recently is the Blue Vac. It's not always about speed as much as our quality. And many times, if you're not careful, the quality of your evacuation may suffer from the speed you're trying to hit. So as you pull the system down, depending on how you hook everything up, if you pull it down too quickly and all the gases and everything don't fully equalize and you're not flashing everything off at a efficient rate, you could also send yourself on a tailspin because say you think you've gotten down to your microns or you start to hit a hard stall point. So you try to do some testing and isolation, whatever, or you do your standing test and all of a sudden your stuff just starts rising right up. Well, that's just going to be because you tried to pull so quickly that not everything got grabbed. So there is some merit to kind of slowing down and not trying to do the fastest evacuation in the world. All right, now in terms of where you pull from, my suggestion is find the largest port closest to the largest internal space as you can. Maybe that's close to the evaporator, maybe that's the liquid line. It really doesn't matter at the end of the day all that much, at least not to me. Be careful that it's not somewhere close to your oil side. So You don't want to hook up anywhere that's going to be directly connected to your oil separator, because you run a lot of risk of drawing oil into your evacuation pump or into your gauge or something. That's the other thing. Always mount your gauge kind of in an upward orientation. Don't mount it ever in a downward one. Like I've screwed myself many times because I did that, not thinking about it. And especially if you're in any kind of like the discharge side of the system, well, that oil will get down into the port of your gauge and then it's just screwed. So be careful with that. End of the day, if you have the right setup, especially the hoses, like that's I'm gonna keep harping on. That's the thing to invest in, is the hoses. If you have it, your evacuation principles that you've known from everything else are going to be pretty consistent. This is the process. This is how you pull an evacuation. Now, some of the things we will do that's maybe outside of the normal. Your standing test, we will typically spend, 4 hours to sometimes 8 hours, heck, even 12 to 24 hours. It really kind of depends on your situation, especially if it's a critical machine that you're not that familiar with, or you've had major leak issues with at some point. You may need to do a 24-hour standing test, meaning that you've pulled it down, you've completed the evacuation. Now you need to walk away and let it sit there in that vacuum for 24 hours to make sure that you can still maintain a proper evacuation or a proper vacuum at that with that system without it leaking or having anything else in the system that's going to cause an issue. And this can be critical because there's a lot of issues can show themselves. More specifically, there's some leaks that they will not show themselves on a pressure test. And I'll do a video on pressure testing and some of these practices and kind of how we would do that on a chiller system. It's again, it's all these concepts are the same as what you would do in an RTU or even on a split, but the scale at what we're doing is what's really changing. So if we factor in just the scale aspect, yeah, that extra time could help us understand that there may be a very small micro leak somewhere that didn't show itself in that first hour or two of monitoring it. At the same time, if we've got a system that we trust a lot and we know is done really well, and we had a really strong pressure test, then maybe you only do a 2-hour standing. I don't recommend things less than that for these size of systems and the volume of refrigerant and just the tubes that we're dealing with. You need to give it time. It has to have time to sit there and stand and make sure that just because you didn't lose any pressure out, hopefully you did a proper pressure test where, again, 4 to 8 hours at minimum for your pressure test, if not closer to another 24 hours. And when we get into the water cooled side of this conversation, which will be a separate video, this scales up even further. Now, to give some values to this, you want to get down to the 500 microns, period. Uh, if you can get down to 400, 500 microns, you're in a good range. And when you're doing these standing tests, ideally, you're going to stay within 1 to 200 microns of your original starting point. Now, if you've got an older system that you know it's just going to have trouble, then as long as you can stay below 1,000 microns at the standing point, pulled down, you have to get down to the 4 to 500 to begin with. But if you give it that, say, 4 to 12-hour window and you stay below 1,000 microns, that's a pretty acceptable condition. Now, if we're talking, you go from there to 1,000 microns in 1 to 2 hours, that's not what we're discussing here. That's going to be too rapid. Something's going on. Either you need to pull some more, maybe you didn't fully dehydrate the system, or you've got a leak somewhere, you need to go deal with it, and it's just not going to be easy to find, and just accept that. So those are the parameters that we're shooting for. inside of those time horizons. If you are just in a hurry and you don't have the ability due to the circumstances to do an extended test, and all you're going to give it is an hour to two, then you really need to be able to stay within 100 microns of wherever your starting point was. Now, there are some cases where, like, say we did a pump down on a compressor and we're servicing the compressor itself. So, isolated everything around it. We needed to fix some stuff on the compressor. There's some of these situations where we typically wouldn't monitor our micron levels all that much. And the likelihood that we're going to be consistent with it's pretty slim anyway. If you have an older machine with older valves and you've got refrigerant pressure on the other side of the valve and you've got a deep evacuation on the compressor side, well, the likelihood those valves are going to hold perfectly are very slim. So your main goal there is, once you've done the repair, the evacuation is just to clear out any atmosphere and non-condensables that may be present in there from doing the repair process. Make sure you give it plenty of time. Don't rush that process. And it is still worth putting a micron gauge on it, especially if you're not confident. But ultimately, our goal is to just evacuate the compressor out and then open your lines up to just get the refrigerant back in there and let everything equalize back out. So I could do a separate video just talking about pump down applications and where we can use that sometimes, and that kind of gets into a hot swap scenario sometimes. If you'd like some more training like this and you got some really good benefit out of listening to me talk about this, go to chilleracademy.com. I have an entire online course that is self-paced, that you can control and that you can take in the field with you. So that's the really cool thing about online courses, is it's mobile. It not only does it go at your pace, but you can take that material, take those lessons, take me breaking everything down, take it into the field with you and review it, watch it, see whatever the lesson is right there at the equipment, and really help you with it, whether it be troubleshooting, a service procedure, whatever it is that you're trying to understand at the time. All that is there in the course, in the palm of your hand. I'd highly encourage you to go check that out and just utilize that as a resource. That is at chilleracademy.com. MTT. Make the time for your family, for your spouse, for your kids. I'll see you around.